Alrighty, hello everybody and welcome back to the channel. Okay, so this is kind of a part 2. We're continuing on the radar. What I've done is I've taken a pivot and I've attached the radar to a pivot. And I want to see if we can get the values from here. We're going to do some stuff with the values. So, first thing I need is a little bit of code. And I have to get it from... Oh, where is it? Way down there. From here. So what I need to do, what we're going to do is we're basically going to be... Yeah, this here. Like that. Okay. So what I have here is... Let me just paste this in here. Don't worry about that yet. We'll update that. Okay. What I've done since the last video is I've taken the outputs. I've just taken the angles, right? We have the elevation angle and we have our pitch angle. And I've separated them into different channels and I'm sending them out as composite so I can read them elsewhere. What I'm trying to do now is I'm trying to add more technology to the system. I'm trying to add some more cameras, maybe some smaller guns. Something like that. So if I detect an object, I can tell the camera to point in that direction and I can target it. Then I can put a laser on it, which can give me the XY coordinates for the object so I can start heading in that direction. Like there's all that kind of stuff, right? So, and that is all part of a broad radar system. Ammo system, whatever you want to call it, right? Blanket of protection, blah, 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 blah. So to do that, we need to be able to save the values that were given from the radar. So I'm hoping that I can do that in this video today. I've tried so far, it hasn't quite worked. So what we need is something like that, but not like that. It needs to say targets. Okay, and then what we need is we need to say target T-A-R-G-E-T equals input dot get bool, and that's going to be channel 1. The other thing we might need and what we're going to do is we're going to end this on tick function way down here. So keep in mind all these other little functions that we add operate within every tick. Every tick, everything in here operates every tick. So what we need to do is we need to take the target and we need to say A equals input get number. Remember we have all our channels 1 through 8. So we're just going to focus on channel 1 for now just to keep things simple. So what we need to do is we need to take that channel 1 and we need to save it. Channel 1. And then of course this is to clear it. I don't know if we're actually going to use this. We will eventually. I'll focus on that in a minute. Okay, so we just focus on that bit of code for now. It's really simple. This tells the code to create a folder. This value is what activates the function to save the number. This number is the number that we want to save to the folder. That's all that is. Okay, so we update that. Now what we also need is another bit of code which is going to allow us to print it's going to allow us to print that onto a screen like the on draw, but we're not going to use it in the on draw. It's this here. Let me explain. Oh, did I save it before I loaded it? Oh, I didn't save it. Okay, so we need that. We'll update that. I saved the microcontroller, but I didn't save the ship. Okay, save that. Load. Nah, I gotta do it all over again. I think I went scroll too far. Holy moly, moly, moly. We just need this. I just need this function here. And then whatever. Targets. Okay. So let's get set up. Let's get set up again. Okay, so we're back to our Lua block. We also need this bit of code, so we don't need the draw part. Okay, now we need to say there we go. And then we need to say input, we need to say target equals. So now by separating the channels, so there's 8 channels that you can detect targets on, and we can take the values from all 8 targets independently. So that's kind of what makes this sort of neat, right? Then what you can do is this is how you can sort of sort through the targets visually and determine, you know, is it a friendly target, is it not a friendly target? Because our detectable range is about 2 kilometers, and when you zoom in with the camera, you should be able to zoom in on an object that far away. We're gonna try it all out, like I say. So then we need let's see, input get number, just like that. And then we don't need this here, but what we want to do is we want to say output set number channel 1 value A. Simple as that. And then this is going to be A, and that's going to equal A. So what this does is this reads this folder, it takes that value, and then it prints it. Now I'm not sure if we can say A, and then if we can duplicate that and go B, C, D, like for each individual target. That's something I'll have to determine. I'm not that, you know what I mean? But we just have a few simple lines of code. That's it. And what do we need to do next? Radar comes in. We need a composite input for the on-off. So, it's going to be radar detect channel 1, which is pretty much what it is. So that's it on off. That's on off. And this one here can be a toggle switch, because here's the thing. So we need a toggle switch to output this value. So every time it detects a target, it's going to save it here. Every time it detects a target, it's going to save it. Boom, boom, boom. It's going to save that number every time. But it's not going to print that number every time. In order to print it, we need a value, we'll call it on, right? Equals, we say input. Get bool, and that's going to be channel 2. So simple as that. So we have channel 1, and then we have channel 2. Now, if we want to save that number, alright, first we're going to do that. Then when we output it, we need to read that number on the output side. And it comes out at channel 1, and it should go out to pitch from the code. All right. So we save that. Let's give it a test. Let's test what we've just built. So we need to take the, I've detected an object, and we need to take the save values. Now this has to be a toggle button. All right, save that. Let's see what it looks like. So what I'm trying to do is I'm trying to save the angle, this angle, so I can then just turn the gun and have it stop. Let's see, all right, so it didn't do anything. Oh, let's check here. I closed this function, but not that function. It isn't outputting any numbers. Let me see if I've got this connected properly. Yeah, pitch from code. It's not connected. Hey, wait a minute. What's going on here? No wonder it's not working. It's not connected. Boy, oh boy. Hate to be an electrician. Whoops. Oh, the drywall's on already and I forgot to wire it in? Ah, my goodness. Where's my hammer? Oh, there we go. There we go. So, as you can see, it's not... Ooh, it did save the number. Saved a number. Where did it save the number to? It saved it when I turned that off. So I wonder if that could be a... Let's try a push button. Because it should move there. Once it has that steady value, it should just move to that value. So it has that value, and then this also has that value, but it doesn't want to rotate there. That I don't know why. You see, it kind of wants to rotate there. But it's not rotating there. So I wonder if there's a way to, now that we have that number, instead of sending it out directly to there, Let me see if we can run this through here. And it would save as soon as it's detecting an object. Let's see if we can do that. Oh, you know why that doesn't work? Because every time it detects an object, it's trying to change that value. So we can't set it from there. We can set it from here because this is a push button here. Aha. If we can save that value, we can then tell the pivot where to move to. There we go. We now have a saved value. Oh boy, this is exciting. So now that we have a saved value, we don't need this toggle button anymore. We can get another push button. So this one here is save. Save values, and then this one here is going to go send the values. So inside the microcontroller, we need a switch. It's going to send this to the on switch, and then we need an input, which probably needs to be a pivot. We'll just call it pivot like that, and instead of being a push button, actually, it probably needs to be a toggle button. Well, we'll see. We'll see. Yeah, because it needs to have a constant on signal in order for it to work. So this here has to be a toggle. So I guess I didn't need to delete that toggle switch. Okay, let's see if that is going to get us through to the next hurdle. What's going on? It's not doing anything now. Oh, the pivot button saved. What? Pivot and save values. Okay. Pivot and save values. Oh, because it's not, there's no off number. Oh, there's no off number. So what could the off number be then? I guess it doesn't matter. Okay. So that worked. When I turned it on, it was outputting that number. I thought it wasn't saving. It's not saving because there's no number that comes through for an off value. So we could read the raw value, I guess, on the screen. And then when we press the other button, it'll be a static number. That works. And then what we need to do is we need to send it, if it worked for there, let's see what it does when we attach it to the pivot. See, I don't know why it's not rotating. Strange. It's strange. But if it was a velocity pivot, it would just spin and spin and spin. I wonder if it's trying to get to. Oh boy. Its current rotation should be 0. Oh, I see. It's trying to get to, but that shouldn't matter, or should it? I don't know. If the number is greater than 0.25, it should still move in that direction. See, why it works with the velocity pivot, if it gives it a positive number or a negative number, and then it moves. And then it stops. It stops because... Weird. Weird. Okay, so maybe if this doesn't work, oh boy, let's try it with the velocity pivot. Like that, and let's merge it here. Then instead of saving the value, it just needs to read the number on and off. So then the off value needs to be 0. It's how we have to do that, right? And then that way, let's see if this works, if this works. So you saw there, it didn't want to work with the pivot. So now we are trying to see if we can do something with the velocity pivot. Again, the velocity pivot, it just needs a positive value or a negative value, and it will spin in one direction or the other. The robotic pivot, it will move to a specific position, I guess. Not too sure what we do there. So we save the values. Yeah, so see, it'll move. Now, what we could do is, right, it'll just slowly move in that direction. And now anything it detects, you see how it's moving back and forth? Anything it detects will be in this range here on the radar. So that's just something to keep in mind. It may be facing the front of the ship, but the range of detection for the radar is in this little square here, or this triangle, I should say. Okay? So that's something we can do. We want it to move to a location, and then we can just do that, and it stops. So we can say, okay, where did we detect the object? Well, the object was detected at these coordinates. So we can then read, does it give us the rotation? In fractions of full terms. That really doesn't do us any good. But what we, does that do us any good? I'm just trying to think if that does us any good or not. What can we do with that number? Well, let's read that number first, and then see what we can do with it. I might be able to send it back in and get a thing and a thing and a... Negative now. What? We're counting down. So it's like the radar. It'll continue to give us a value, but a negative value. Okay, weird. Weird. That is. Oh, nah, there's probably an explanation for that. I'm sure there's an explanation somewhere for that. Okay, so if we take that value, let's just see if we can measure that rotation instead of the radar rotation. Let's see what happens there. So this is kind of what you need to do. You need to be engaging with it. You need to build it and code it, and then spawn it in a million times and say, okay, well, what if I do this? What if I do that? And just be playing around with it. Look at that. Look at that. So, there you have it. That's going to do it for this video. In the next video, I will expand on this a little bit more. So as you can see, we're printing the rotation of it, and it's going to continue to go. So now, if we're detecting an object here, we can then say have a camera attached to the gun, and we can spin it, and you know what I mean. And then there's a little bit more that we can do here for this, right? So I'll just quickly go over it, and then that'll be the end of it here. So we can take a camera like this, which has like the night vision on it, and we can set it up here. We can also take a laser. What's the point? No, we want this camera here. Is what we want. Okay, this camera has a laser on it. This camera has a laser on it, and when I'm gonna go through this in the next video, the laser gives you the X, Y, and Z, and that's where we sort of get into XYZ to XYZ, where it's really important. So this is the camera that you want. So now what we have here is we have a full sort of, but this would be one type of radar, right? And you would need to build another one maybe for something else. That's sort of what I'm kind of getting at here. This is one type of radar. What does it do? Well, we could print that line, and we could also print that line. We can scale it. See, I'm really close to it, but if we detected an object at range, let's see here. And then it would move, and we could say, okay, where's the object? And then we use the camera to detect it and all that sort of stuff. So that's kind of where we're going with this. So that'll be doing it for this one here. At part 3, we will continue on, and we'll get the camera working, and we'll hook it all up. And this is what's going to help us with our detecting the enemy. Then we'll go and we'll fight the enemy. We'll see if it's any good. So thank you so much for watching, and I will see you all in the next one.